Hi everyone. Let us learn the next topic, that is bonding in carbon, which is a covalent bond. First, let us know the definition. A covalent bond is a chemical bond that involves the sharing of electrons to form electron pairs between atoms. These electron pairs are known as shared pairs or bonding pairs. Now, there are different types of bonding, but when we talk about covalent bonding, it usually happens between nonmetals. So here mainly the electrons of two atoms, they share the electron, and that's the reason why they're called as shared pairs or even bonding pairs. So let us take a few examples and learn them. So the first molecule we have here is hydrogen molecule. So we all know that hydrogen is a non-metal and the atomic number of hydrogen is 1. So here you can see on the screen that on the orbit there is one electron that is denoted as a dot, and there is one more electron which has been given the multiplication sign. So here these are the two electrons representing two hydrogen atom. So mainly here we all know that hydrogen is diatomic molecule, means two hydrogen atoms combine to form a hydrogen molecule. So hence it is called as diatom. So here, mainly what exactly is happening is the two hydrogens share their electrons. Hence, you can see here a shared pair of electrons are formed. So that's the reason why covalent bonds are also involving shared pair of electrons or bonding electrons. Now, next let us understand another example. Oxygen. So we all know oxygen belongs to group 16 and it's the first element of group 16. It is also a non-metal. When we look at the atomic number of oxygen, we know oxygen atomic number is 8. And when you write down the electronic configuration, it is 1s2, 2s2 and 2p4. So in that case, we can expect two lone pair of oxygen, and so we will also understand the distribution of electrons. So here I will write oxygen is having atomic number 8. So it is having 1s2, 2s2 and 2p4. So according to NLX rule, so if you count the number of x, we get the atomic number. So 2 plus 2, 4, 4 plus 4, 8. So whatever electronic configuration we have written is correct. So now let us understand how there is distribution of electrons in orbital. So we're only going to take the valence orbital, valence shell, that is 2. So here in 2s, we all know that 2s is having only one orbital and the two electrons are distributed. Now similarly, when you talk about p orbitals, there are 3 p orbitals and there is 4 electrons. So according to Hund's rule, we have 3 electrons filled and the fourth one is filled on the first orbital. So now according to this, so this is 2p. So you have 2 electrons on 2s and 4 electrons on 2p. Now together there are two lone pairs. So you can see that these orbitals on 2s and one of the 2p, they are completely filled. So they are called as lone pair. So now the lone pair are represented on the top and bottom part of the oxygen atom. So they are the lone pairs. Now the remaining are the two non-bonded orbitals, non-bonded electrons. So here you can see that the last two orbitals of 2p are having half filled electrons. So in that case, another half filled electrons of the adjacent oxygen is going to form a bond. So here what you can see, the conjunction here, okay, between the oxygen, what's the bonds formed there, I mean the 4 electrons, they are the electrons. So that means that there are 4 dots. So the 2 electrons are of one oxygen and the other 2 electrons are of other oxygen, and hence there is a double bond. So here students, what you can see, these 4 So these 4 electrons, what you can see here, sorry, so here oxygen, oxygen, and here you have 4 electrons. Okay, so these 4 electrons that I've drawn here, these are representing the two half-filled orbitals, that is the two half-filled 2p orbitals of each oxygen. So in that case, oxygen gets a double bond. So here the two bonds are representing 4 electrons. So that's why again oxygen becomes a diatom. So because two oxygens form a double bond, again here there is sharing of electrons between two oxygen atoms, and hence it forms a diatom, or it is a diatomic molecule. Similarly, we have nitrogen. So nitrogen also, in a similar manner, we can understand nitrogen atomic number is 7, and when we talk about the distribution of electrons, it is going to be 1s2, 2s2 and 2p3. So now let us only focus on the valence shell. So in the valence shell we have 2s, and then we have 2p. So there are 3 p orbitals, there are 2p, and there are 3 electrons in 2p. So in that case, 2s becomes a lone pair. What you can see here on the extreme left and right of the two nitrogen atom, they are the lone pair, and this is the 3 half-filled 2p orbitals. So in that case, there can be 3 more electrons of another oxygen to form a triple bond with nitrogen. So that's the reason why you can see here, okay, 3 bonds between nitrogen. And here in the junction here, again you can see there are 3 dots and 3 into marks, which means that 3 bonds are formed between nitrogen. So nitrogen is an example for triatomic molecule. In this example also, students, we should understand that nitrogen again has shared the 3 electrons. Two nitrogen shares 3 electrons with each other to form a triple bond. Similarly, we have methane. So we all know carbon valency is 4, and when you write down the valency of carbon, configuration 1s2, 2s2, I'm sorry. Carbon valency is 6. Sorry. Carbon valency is 6. When we write the electronic configuration, we are writing it as 1s2, 2s2 and 2p2. So now let's focus only on the valence electron. So we have 2p, 2s and 2p. Now according to hybridization, one of the electron from 2s will jump to 2p. Totally there will be 4 vacant orbitals, that is sp3 hybridization. Now the into that you can see around carbon, these are the 4 electrons of carbon. Okay, that is 1, 2, 3 and 4. So these are the 4 electrons of carbon. Now the other 4 dots that we can observe is electrons of hydrogen, because we know atomic number of hydrogen is 1, and hence hydrogen will have 1 valence electron. So now totally there will be 4 electrons of carbon, of 1 carbon, and 4 electrons of 4 hydrogen, and there again they form covalent bond. So when you have to draw the structure of methane, we are always representing it by a single bond and 4 hydrogens around 1 carbon. So methane is the simplest hydrocarbon, and this is an example for covalent bond as well. Thank you very much.